What is up? What is up? What is up indeed? What is up, my good friends? We are jumping right back into it. All I did between the end of the last stream and now is sleep. And as these things go, I was obsessed all night long. I couldn't stop thinking about how to move forward with this project. So I figured, what better way? Well, I am waiting for the day to warm up, things to come in the mail, to just start right back where we left off. So without further ado, we will pop back into SolidWorks, and I have a new plan for today, at least for the first part of the day. What I would like to do is get this knuckle, I guess you can't see what I'm doing if I don't show you. I want to get this knuckle and the top section of this pedestal printed so that I can put the motor in and start to evaluate how it behaves together. So I want to print this gear, which we can do right away. We don't need to wait on that. We do need to edit it though, so that we have the flat edge. One trick I learned about press fit gears like this is to make them almost size on size, and then you can always heat it up as you're pressing it onto the shaft, and that'll give you an even tighter fit. So let's see, here's the shaft. I got one of my motors right here. I did. The shaft is a D shaft all the way down to the collar here, so we'll make our entire... Ooh, that's something to be aware of. We're gonna have to move some stuff around after all, because our gear here can't be... Well, we've already got a lot of this laid out, so maybe we just edit the gear. But if we take a look at this, our gear is overlapping. The gear doesn't need to be longer than 0.29. There's nothing that the gear can interact with if it's longer than that. So we're just gonna come into here, and of course all these things are driven off of a sketch, which is up here. So that should have, yeah, that took our gear out of the little collar here for the motor. It left us mated with the end of the shaft there. But what we didn't do yet is extrude this sketch. I'm going to use this other face as the terminating face. Dunzo. Looking swifty. And this fillet is not going to help us for 3D printing. And that shaft looks pretty weak for 3D printing, so let's go ahead and add a fillet up top. And the cool thing is, it doesn't matter that it goes all the way to the edge. Because, look at that. So, that will prevent the end of the gear from, whoa, what's going on with my hair? Just kind of snapping off, but it also allows us to get away from the gear teeth kind of as quickly as possible, because I think we're going to need some other features in here. Uh-oh. What are we looking at? Why are we mad? I love looking at this gear roll around. We're about to do some advanced SolidWorks Pro user techniques, so pay attention. Give me 1 sec here. Let's print this gear. Let's see if I can pop up Bamboo Studio. Bamboo. I need to swap the filament. Is ASA good for gears? We can run with the ASA that's in the machine. We're going to save this as a 3MF. There's all kinds of disclaimers and stuff about not 3D printing like master car parts. I don't know. You put something on the internet, it's going to be kind of hard to control what people do with it. So, while I agree that you shouldn't just be out here profiting off of someone else's modeling, don't tell me what I can't do. Boom. There you have Bamboo Studio. It's tiny. I'm gonna load my PLA real quick because I don't know how. Let's just roll with it real quick. Let's see what happens. Generic. How's it going on this Saturday morning for everybody? Where the heck is the ASA? Generic ASA. It's right there. It's right there. The crap. How do I do that? Why can't I change my filament to ASA? I don't know. Oh, I don't know. I just did it in the P1S, which is what we needed to do anyway, so. Okay, and then for strength, we only have 2 wall loops, which, I don't know. I like to go 4 and internal solid fill, sparse infill, we're gonna go gyroid and 25%. That's my go-to strength settings. Wow, this sucker is like just solid. 4 walls. We'll see what happens. Okay, we have sent the print. Later today, we have to go install that radio bracket. Did I? I don't think I streamed that, but maybe I did. Yeah, I did. It was like the 15-20 minutes before church. I remember. Okay, we're done with bamboo. So hopping back into SolidWorks, we got our special gear now, and we only want to print this interface. So here's what we're gonna do. Here's the advanced SolidWorks technique, right? We're grabbing our gear, we're grabbing our knuckle, we're grabbing both motors. We're gonna do form new subassembly. Oops. Let's do it based off of this though. Okay, so everything should still work. But it doesn't. Why doesn't it work? Let's take a look at that in just a second. So we'll call this the L as ASM. Yeah. For some reason, it doesn't want to work with the gear mate anymore, which is a bummer. But let's take a look at this. So we need to start looking at how these components interact with each other. So what we need to do, we need to be able to keep the relative positioning of this gear to the center of the knuckle up there, but we want to be able to move this motor around. So we're going to get rid of this distance and this distance, mate. Also, before we do that, wow, it's very angry. I see what's happening. We have that, and we shouldn't have that. That was the wrong way to do that. Boom. So that goes up there. Now we can start dimensioning the origin off these planes, which are going to be the exact same dimensions. And now this motor should just be able to, spin about that face. And the reason I needed to do that is I need to find the best angle for the connector, because we're getting really close to the edge right here. Let's do something. Let's do something that'll help us. We're gonna draw a circle just so we can mate the center of that gear to that circle, and then move this whole assembly around, rotate it around, do whatever we want to do, but it's always the same distance to the center of the knuckle. So those two mates we just added last, the dimensions, I'm gonna get rid of them, and how are we gonna do that? We could mate this, one of the planes in this tangent to our circle here. And then the other one, the other plane, to the origin. Okay. Now, this gear can slide around, but it's always at the same distance. And all we have to worry about is where we're going to put the connector on the motor. One thing I'm thinking about, or I thought about a lot last night, was does this motor have to be in the center? Would it help us to move it off to the side a little bit? See, really, ideally, we have that situation, which gives us the most space between this edge and the outside edge here. But it doesn't work with the gear motor the way that it is. So if we just move this up, and then instead of an entire face, we have just this corner that's a little close to the edge. But even still, I don't enjoy that. So if we were gonna try to get this face to be pointed towards the center, we'd have to move this dude off quite a bit. I don't think that's possible. So I don't like that either. We're gonna go with that seems like the best setup. Is that what we had originally? Could be. Could be. We'll make these two faces parallel. And then our goal is probably just to get them as close to each other as possible. What does that look like in real life? I've got the motors here. Set a distance here of 0.03125. So if we undo or just suppress all of these other things, and undo these two mates, yeah, we're in the exact same situation that we were, just on the other side. Yeah, so all of this was unnecessary, but worth a look. Uh-oh, getting a phone call. Okay, so I was just spinning this around and thinking about it, which is what you got to do sometimes. And I think what I'm going to do, I'm going to start with making this be an offset of 1/8 of an inch. Is 1/8 good? An eighth is plenty. Nah, I like the 16th. We'll just leave it. But in that case, we need to cut a hole for the gear not to interfere hang on. We need to think through this. So the way that these motors mount is a couple of little screws on the front into this gearbox section, but I'm not a big fan of that. I don't think I've got the right screws anyway. I do like clamping motors where I can. Let's do something real quick. Something easy. Okay, so that didn't work. So that hollowed up our knuckle here. And we'll be able to take the distance mate from these two and get rid of it. We'll be able to take a look at this. Oh, mate. This face. To this one. And we're back in business with constraining this motor. So, other things that need to happen is we're going to have to shave just this corner for the gearbox. There's no way to clock these gearboxes, is there? That would be really cool. I don't think so. I want other people... Oh, our gear's already finished. I'll be right back. Okay. Dang. Our gear finished printing. Give me 1 second. Here's our gear. And here's our motor. So you can see the little D profile in there and the D profile on the shaft. Obviously, we're gonna make them kiss, and they don't want to. So we got it started. Actually, we probably don't want to get that all the way on there, because we're going to need to take it off to let it pass through whatever mounting solution we come up with. But yeah, not bad for a first try. Pretty cool, actually. So now we need to come up with a way to mount this motor to this knuckle here. We should look at how much of an interference it actually has. That's bothering me for some reason. I keep thinking I'll deal with it in a minute, but my brain wants me to deal with it now. So that's a pretty ugly interference there. We could solve a lot of the problems if we just scaled this up slightly, but I'm afraid to do that because we already figured out the teeth mesh kind of a thing. So I want to avoid that if possible. Well, let's do something like this. So we'll go actually, what we should have done from the very beginning, let's get rid of that. Let's go back into our sketch that makes the shoulder joint. Let's do an offset. Why is this happening? Okay. We're gonna get some errors from that, I'm sure. Okay. So now we can begin to see, yeah, we got plenty of room actually for the connector and everything up here. It's just the corner of the gearbox that we're not super kosher with. So let's do a eval on that. Oh. I fully expect that to cut through our little situation here, which is not ideal. However, we are locked in. What are we locked in by? This gear's diameter. If this gear was larger, we could move the motor further in and away from this edge. Yeah, because that's ugly. I wish this gear was bigger. That would be really cool. Because no matter what, the gear is barely bigger than the gear box, which is, that's our limitation right there. Make subassembly flexible. And there we go. I couldn't remember the name of that feature. So what can we do? This is already barely a thing. It's only 1/8 of an inch thick up here, right? Yeah. So we could go 875 on it. No. Alright, so what we're gonna do, we're gonna thicken it but to the outside, so we can leave the inside geometry alone. And in this way, that's gonna be a mess. Okay, we're just gonna do it though. This is a hack. Don't do this at home. We're gonna convert this into T right here. Oh, we need to do a boss extrude. We're going to add whatever thickness we want. I think we want this to be pretty thick. We're going to extrude it down. Okay, that doesn't really detract from our view. So now we have a thicker neck section here. So we could just make the whole thing bigger, right? So the whole neck section now is 2 1/4. And to get out of this, I think we just need 1/8 of an inch. So we already gave that a clearance. We're gonna do another 1/8 of an inch on top of that. Then when it cuts, it shouldn't pop out the side. Actually, we're gonna go in here and do it. We're gonna fillet these. They're not really big fillets. But instead of popping out the side, now we've just got this edge here. So we'll go back over to our assembly. Everything should be happy. Well, not in this one. Okay, and where'd we end up with on this guy? 1.875. So we'll cut that. We'll do an extrude cut. The depth of which I don't know yet. Should have looked at that first. What was it, a 1/2 inch? Alright, cool. So this is actually giving us a lip to have the part right on that's not external. So that'll interface with this edge here. At least I hope it does. We're gonna delete this chamfer too. These were aesthetic. We're not ready for that yet. So right now, this assembly can essentially just drop into place. Hang on, it's my mom. Yeah, this assembly will drop into place, and if you line up the gear teeth, it should be able to drive itself around. So what we're gonna need to do is we're gonna have to add a pass-through for the wires, but that's like trivial. What we want to do more of is probably we need to give this more space here. So if we hop back over to the pedestal and this cut that we did, we set it off of a different priority. But we should go off of wall thickness. So the wall thickness here, 1/8 of an inch should be fine. Which gives us a diameter of 2 inches on that. Perfect. So come over here. This should be equal to 2 inches. Minus our gap, obviously. Okay, what's our problem? Oh, it doesn't cut anything anymore. That's cool. So this will drop in. Yeah, we can essentially just mount this azimuth motor. Let's close some of these assemblies. We can mount the azimuth motor right to the floor of the pedestal, or the this knuckle here. The one thing I'm concerned about is where the mounting holes are. Yeah, and they're kind of annoyingly right where this gear is. Give me 1 second. I'm gonna look for some hardware. So I do not have, nor do I know where to find the size hardware for mounting these motors. Not in town at least. So we're gonna look at the motors that I bought. What size is that? Holy cow. Okay, I've got the spec sheet pulled up here. It doesn't even call out the motor mounting. How the crap are you supposed to mount these motors? Let's see. Did this guy actually use threads? Or did he model them? Oh, this is the... M1.6. Disgusting. There's got to be a better way to mount these. Let's see if McMaster has M1.6. How long do they need to be? These are stupid. This is a stupid screw. I hate this screw. We're gonna do something different. We're gonna come up with something better for this. This is ridiculous. Like, that's just ridiculous. That is insane. Look how tiny that is. I mean, I guess it could work. What else can we do, guys? What can we do on mounting this? People must use these screws because they wouldn't sell these motors and stuff if they didn't work. So as a socket head screw, I assumed that would be the smallest head that would function for our purposes, but yeah, I hate these screws. Also, what a ridiculous way to model threads. Come on, guy. What are you doing? Of course you're not able to mate that because it's a ridiculous... These screws might be a deal breaker. So we've got a couple of problems here with the screws. One, it interferes with our gear, which is, you know, not cool. And B, they're just so freaking tiny that I don't think that they will hold the forces that we want them to. How the crap do you get such a high gear ratio motor and then hold it in place with these tiny little screws? I mean, technically we only need 2 mils. So probably those other ones were better. Oh crap, it's gonna be windy today. These screws are making me so angry. What right do they have to exist this tiny? Well, we're interfering less. It's still not ideal. What can we do? Point 2362. That's so gross. I hate it so much. We just reduced the reliability of the gear. Yeah, that's not a fun time. We're gonna do some funky stuff here. So if that was 2125. Watch, this is actually gonna be okay. I really hate these little tiny screws. I wish there was a better way to do this. But we're gonna be okay. No panicking. Anakin. The next challenge is going to be to find an M 1.6 screw here in town. Because I am not about to pay $13 freaking dollars for 25 screws to be shipped to me. Where do you even get little screws like that? Who would have something like that? We used to have a nut and bolt shop that had a bunch of cool stuff, but then they went to just construction hardware, and they're like, even with that, they don't do metric fasteners. And I'm like, what is the point of you then? Okay, so I really want to print this ring. I want to print the ring, the gear, and the lower half of the upper half of the pedestal, the lower half of the knuckle, and the gear, and then see how those things mesh together. I want to do that before I go too much further, so for the meantime, let's go ahead and start designing with that in mind. We're gonna hijack or skip some steps for the final design. So we should have a sketch here within this part that is suppressed. We're gonna borrow him to make a well for the motor to sit in, so that it has more than just this rinky-dink little baby screw at the bottom. And we only needed to go up, what do you think, to that second one? Where's the motor? What did I do with my motor? There it is. It could go in the hole all the way to the top one. Down in the West Texas, town of El Paso. Okay, and as long as that doesn't hit the other motor, which it looks like we are barely clear, we can slide. What did I make that on the wall thickness? Oh, 50. .2 millimeters is 3 passes. Okay, so we'll just slide this motor into place. We could even put grease in that gearbox well there. Then we can secure it with these stupid tiny little screws, and that'll just hold it down, but they're not responsible for holding the torque really. Radius at 0.8 was 1.6 millimeters. So hitting tab. Do a copy with mates here, and instead of that really dumb edge on the motor, we're gonna use the What is happening? Well, Copy with Mates isn't working for us today. So we'll just throw them in here. Concentric all alike. We're going to mate this proper down to the bottom of this face. And that's looking all right. So let's do some tidying up here. My computer sounds like it might need a break. Alright, so that's what we're looking at. That's good. Oh, yeah. We need to come up with an interface between the top of this and the bottom of that. So my first thought is to just create a well for the grease to run in. And that lip would be 1/6. That's 2 passes or 4 passes of the 0.4mm nozzle. Because remember, we're 3D printing this, so we want it to be decently in tuned with the limitations of the 3D printer. And this doesn't need to be very deep. Okay, so we can just fill that with grease, and then on this other side, on our main man here, we're gonna give it 0.04. 0.4 is a lot. And a quarter inch is a lot, isn't it? It's really not that much. So if we were to mate this to the bottom of this, what we could do, how's our gear mesh look? It's a little low, isn't it? So let's take this quarter inch and subtract a little bit. Okay, cool. So now we have a gap up here, but we're riding on this. So we're riding on this edge here. Is this part necessary for anything down here? No. So let's just suppress it. And one thing I noticed about interfaces like this is they were adding like castellations, I think, to further create friction between the grease and the axial movement, which would act as like a damper, which is what I want. I want it to move super smooth, like it weighs 1,000,000 pounds or 100,000 pounds. Wow, none of my constraints took on that one. That was fantastic. Let's get this going here, 15 degrees. We'll do a circular pattern on this. Bump that up. Eight seems good. We have that at a quarter inch. Looks good to me. What do we not like about that? Oh, because we suppressed that. That should be enough to start printing some stuff. So let's just try it. We'll go ahead and add some chamfers for pretty ladies. Oops, did not want to add that there. Try that. So we'll hop back into Bamboo. Our little gear is not going to work anymore because of the stupid hardware requirements. It's why you model with hardware. I used to get in trouble for adding all the hardware to my assemblies, and you know, it takes a lot of time, but more often than not, I won't say every time, but more often than not, when my assemblies were introduced to production, they worked first try because I had very little issues because I was putting the hardware in the model. So, where's the cut? Can't we cut? Yeah, we can cut. Okay, the thing about this part is it's not fantastic for 3D printing. We're gonna have to do a lot of work on that. But for now, I'm okay with that just being something we have to deal with. We need to go back into SolidWorks and make a new gear. We're not. Yeah, we're just saving the gear off as a new file format, or as an updated version of itself. Boom. Let's set this just back to draft quality. We want supports on this part. And I think normal supports on this are okay because it's just flat geometry that it's going to be supporting. we're gonna warm up the printer. We want to unload this. We're gonna slice. Okay. Now I'm gonna go hook up the AMS. And we're back. Gotta stop buying cheap filament. Dried up in the extruder, cracked itself, and now I gotta disassemble the AMS again, which is always a joy. But we're going to... What's it doing now? What are we doing now? Wait, did we preview the slice? Okay. We're going to send this to the printer. I got some other work to do today. We'll come back and check the fitment of all these parts and continue this later in the afternoon. So I appreciate you being here. We have a lot of work to do. It's getting exciting though. We've got some good jumps on these parts, so stay tuned. Make sure to follow for updates, and eventually I hope to release these files so you can build your own. But have a good day and be productive this weekend.